But now let's start with the main topic of the course, Linux, and why is Linux important for HPC. We can take a look at the statistic. So there is a list of the top 500 supercomputers in the world. And if we look at some historical data, then we see some point in the 90s and before there was Unix dominant operating system on these large-scale compute clusters. And then Linux took over, and now mainly all of the supercomputers are running Linux. So it seems to be a good idea to run Linux on these HPC systems. And we will take a look at why this is the case. So what is Linux anyway? Linux is the kernel of an operating system, the Linux kernel. And if we take a look at what this means, we can split the software layers on our computer. So we can split it into some layers here, and at the bottom we have the hardware, and at the top we have the user, and in between we have the applications, your scientific applications that you need to do some calculations, but also maybe a graphical user interface, a text editor, or any other program. And then in between your applications and the hardware, we have the operating system. And we can split this further up into these low-level system components and the kernel. So the kernel's job is to talk to the hardware and manage access to the hardware. So there are no conflicts between the programs when they try to access the resources on your computer system. So the process management, memory management, file systems, and so on. And it contains the drivers so it can properly talk to the different types of hardware. And then we have these low-level system components. So these are system daemons that run in the background, some core libraries, and so on that basically implement some services for your application. So application does not need to know how to, for example, create a graphical window on the computer. It just needs to talk to the service that enables this application to create a window. And these then belong to the operating system, so they work hand in hand and then allow you, the user, to use your applications to make the best out of your compute system. And Linux, as said, is strictly speaking just the kernel here, this part that talks to the hardware. So it is a project that was also started in the beginning of the 90s by Linus Torvalds, and back in the day, Unix was the dominating system. It was quite expensive and closed source. So he thought it's a good idea to have make a new operating system that is run as an open source project. This means that everyone can participate in the development. Everyone can look at the source code, for example, to check for some flaws or some bugs, and also help to remove these bugs. And everyone can use it also for commercial purposes. And Linux is compliant with POSIX, so this was an advantage for the already existing programs back in the day, because then they were easily ported to the Linux operating system when they were already running on a Unix-like operating system before. Now, you not only need the kernel, because you also need this other layer of these daemons and tools and so on to run your computer, to have a complete operating system as explained. So often what you get is the Linux kernel and a set of applications. So this is usually GNU software, suite of applications, and these belong to the GNU project, which was actually started before in the 80s by Richard Stallman, and it contains all the tools that you would need to run a computer system, compilers, core utilities, the shell, desktop environment, and so on. And a Linux distribution is basically a set of the software components packed together. So it's a selection of these software packages packed together with the Linux kernel. And there are different distributions. So here are different types of distributions. So we have some distributions that are fit for server, but also workstation use. For example, Debian or Ubuntu, you can also easily run on your notebook. And there are also some distributions that are often run on server systems like Red Hat or OpenSUSE. And here these distributions are supported by these companies that also sell you support for these systems. So if you're a company and want to run these distributions on a server, for example, you will get support and help in case of problems. And they are also more specialized distributions. For example, in a security context, there it's then they contain a lot of security tools, and it's a little bit pre-configured, you could say, for these special tasks. Why is Linux important for HPC? One thing is the openness. So you will get the support from these large companies, and it's a free and open source and free license. So you can always look into what you are running on the system. It's, these operating systems have very low overhead and higher system stability, and they allow for multiple users to run their applications at the same time on one system. So they have multi-user support, so the systems can be shared easily. So they have extremely powerful text mode, as you would prefer on a HPC system. So no graphics is needed, so you don't have the overhead of doing all these things on the system, so they can concentrate on doing the calculations. So it's also, you have an easier access to these systems over the network, over the internet, where you may have network stability problems. It's easy to automate your tasks and do some scripting of the things that you want to do on the cluster to help you be more efficient. So the cluster usage is throughput oriented. Therefore, you define what kind of application should be run with which parameters, and then they are being executed on the compute cluster. And this um, is not done interactively most of the time, so it can be optimated on running as many computations as possible on the cluster and make good use of the hardware. And in the end, we have this flexibility of using a lot of already existing scientific libraries and applications that are already running on Linux, and it's easy to get help from the community and also find problems and fix them yourselves because you have access to these open source software, and then you can also give back and help other people. So today what you will learn is how to use an already installed Linux system, because the cluster is already installed and is operated by our cluster administrators. So we will take a look at the user level and the command line level, how to use such a system. And we will not see how to install or configure Linux. It's already there. And or how to migrate to Linux, or how to perform administrative tasks in Linux. But practice makes perfect, and you can, after the course, still continue practicing and your training with Linux. On macOS, it's quite easy. You just open the terminal, and it's a quite similar environment because macOS is also a Unix-like system. And on Windows, there is also the Windows subsystem for Linux that also then contains a Linux environment inside of your Windows. And there are also other possibilities like using a virtual machine or even booting your system with Linux, with a live Linux distribution from a USB drive, or just continue using our clusters and um, then gain some experience there. If you want to use, for example, a virtual machine, then distributions for beginners would be, for example, Ubuntu or Linux Mint.